This video is going to show off various kinds of unusual metals and some of their applications. First one we're going to show off is indium. This is a 1 kilogram ingot of technical grade indium. And indium is a very unique metal. It's incredibly soft. You'd be able to make a substantial dent in it with your fingernail. And it's used for everything from laser diode solder to cryogenic sealing to those tacky blue LEDs they like to put it all over everything. This indium bar and all this other stuff is going to end up being for sale on proxybid.com by an actual auction service. Alright, let's put the indium away and show off some of the other stuff. This thing here is a reel of indium and silver solder. It's 97% indium and 3% silver. As you can see, there's quite a bit of it on the roll left, especially if you're using it as intended. This would be enough to do many 100,000 laser diodes, and it's very thermally conductive. You can also use it as a gasket material for crystals. It's very thin foil like material. This one here is a slight variant. It's a little different. This one is indium and tin alloy. Indium tin makes a very high quality eutectic alloy that melts at 138 degrees Celsius, which means it's a little higher than boiling water. This makes it possible to solder a lot of heat sensitive materials in place, and this roll is substantial. It has a good amount of weight to it, and it's available on proxybid.com. This here is a Xenon triple point demonstration capsule. It has a tube of very high purity xenon gas inside that is at such a pressure that when you lower it, you'll actually see the xenon liquefy. Lower the temperature a little more, you'll actually see xenon start to freeze in part of it, and then it'll have liquid and gas all in the little module. And these things are very expensive. Several $100s at the very least. If you're able to get one surplus new, because it's a xenon based one, it probably would be a custom job that cost you over $1,000. Very neat sample for an element collector. This here is very high purity gallium metal. It's pyrotronic grade, and it's made by a company called Johnson Matthey. Most people are familiar with them as a source of platinum group metals and other types of precious metals, but they also do make semiconductor grade gallium. This bottle has never been opened, and it still has the purity. As you can see, it's kind of a silvery metal, and it melted at one time a little bit in the bottle. That's why you can see it like that. If I were to hold it in my hand, it would melt quite easily. This here is a very interesting gadget. It's a cesium vapor arc lamp. The tube is similar to the type inside of a sodium vapor lamp, although it's a lot higher quality than the tubes inside of a sodium vapor lamp. It has a power of 10 to 15 kilowatts and is actually a continuous duty lamp. You could run it pulsed as well. In practice, this device was used with pulse width modulating driver to make it simulate the thermal heat signature of an enemy aircraft engine, and so it would confuse missiles and make them lose their tracking. Then if the missile got a lock and you got it real close to range, it can go into a burst mode, sort of like a strobe light, and make the missile think that it's within kill range and blow up a little early. And that would save an aircraft from being shot down. It's got pretty serious heavy duty electrodes made with silver bus bar type wire and a high speed fan type device on it. It's got a real nice gold plated reflector, and something like this is something that would be extremely hard to find, and definitely a good thing to show people about cesium, of one of the more unusual applications for this rare metal. And I hope you enjoyed the little discourse on the elements.